Okay, it's not a very nice day out here today, so I've been asked to do a little bit more video on the radio units I've got. So rather than working on this thing, trying to do any more jobs on that, I'm back to the radio, which is sort of in my garage here, so a little bit drier. Now, right, where do I start? Well, you've seen the radio on a couple of the last videos, so what I'm going to do is I'll turn it on.
Are entirely unfounded,
and as you know, the MP3 player starts playing, so I'm going to pause. I'm going to stop that, push pause. Now I'm going to turn on the PMR radio, 446 megahertz PMR walkie-talkie, which is built into this unit. Now, when you've previously seen this, I've had an antenna which I calculated roughly as being a full wavelength antenna. I've had that plugged in on the antenna socket there, but I decided that it wasn't really working up to spec, so presumably it wasn't tuned to the right length. So I decided, seeing I'm messing around with a few of these, to invest in a VSWR meter, or SWR meter for short. Standing wave ratio stands for. This one is a Watson W420, and it covers a frequency range from 118 to 530 megahertz, as you can see clearly there. And this button that's got on here, AVG, I think that's average, and then pushed in is for single sideband. Now I've just got it in the average position, which is out. Now we have a few other dials here. We've got forward, reflected, we've got calibrate, and SWR. Then here we've got range for the power, which is the minimum watt range is 5 watts, mid 20 watts, and maximum 200 watt range. So basically this should give you a direct power meter reading on the scale. So if it's on 200 watt scale, you're looking at that center scale there, which is 0 through to 200. If you're looking at the 5 watt scale, it's the bottom scale there, 0 through to 5 watts. Yeah, nice and simple. So forward, reflected, cal. If I set this to cal and key the microphone, the idea is that you adjust the scale on the meter to maximum, to full scale deflection. Now, because I'm only using half a watt of power transmitted from a PMR handheld walkie-talkie, I'm not going to get it to go full scale deflection. In fact, all that it's actually going to do is most likely go to 0.5 of a watt. That's if I'm lucky. So if I key this, it's actually showing even less, and you can see I've got that tuned all the way over to maximum adjustment. Yeah, so it's only actually giving me about 1/4 of a watt at the at the meter. If I put this to forward, well, I'm saying quarter of a watt, but realistically that's the calibrate scale. It's not, strictly speaking, a watt measurement. If I put this to forward, this in theory should give me the proper watt reading. It's saying I'm actually transmitting forward energy of less than quarter of a watt, so not very good. As I say, that's working on this antenna which I cut some time ago as a bit of a guess. I guessed that it wouldn't work particularly well because a full wave antenna generally doesn't work as good as a quarter or a half wave. But because I was mounting it external to the case and I wanted an antenna which looked more World War II period in length, I went for trying to make a full wave one. But I can see now that was an error. What I really need to do is, if I want something long, is I have to work with something more experimental, or make a dummy casing and just have a quarter wave antenna built in the base. So if I put this to reflected, this will actually tell me the amount of signal which is being reflected back into the transmitter due to the antenna length being the wrong length. Now that is actually telling me that it's reflecting about less than quarter of a watt, about say, what would that be? It's about 20% of its power is being reflected. So it's a very poor antenna basically. So I thought, well, let's get back to basics with this thing and go for messing around with a quarter wavelength antenna. Now, off the top of my head, I can't remember exactly what a quarter wavelength should be on 446 megahertz. What I'll probably do is I will calculate it and I'll put it in a comment bubble on the video when it goes up on YouTube. I think it's something like 16 or 17 centimeters for a quarter wave. Yeah, so what I did was I got some simple copper wire. This is a fairly thick gauge. It's probably 6mm power cable. See, nice thick copper wire in the end there. But you can see that if I put it against this tape measure, if I put it on a, you can see it's about 3 or 4 millimeters in width, the actual conductor. Now 17 centimeters should be all the way over there. So what I did was I cut my wire, started off at that point, but in reality they end up being a little bit shorter than 17 centimeters by the time you've tuned them, due to various bits of say, I won't say bare conductor, but various bits of loss which you're gathering up inside the casing due to using soldering bits of coax on the actual circuit board of the walkie-talkie and coming all the way up to the socket. So you actually got little bits of signal leakage along its pathway. So those bits of signal leakage are acting like an antenna to a degree, but the place where you want the actual signal to be sent from is external to the box on the actual antenna itself. So to get a really good quality job, the idea would be to really mount the walkie-talkie section closer to the antenna, or use a very low loss coax. I will put some low loss coax details in a bubble on top of the video, because I can't remember them off the top of my head. Now, if we look at this wire here, you can see the total length of this wire is around 15.4 centimeters in length. Now, this little bit here, while I've been messing around, is what I'm actually pushing into the SO259 socket, the coax socket. So basically I've stripped off a bit of insulation there, and if I measure the actual length, which is still insulated, it's 14.4 centimeters in length. Now, if I rotate this meter around, you will see what we have is we've got a coax which runs off, which goes to the antenna socket on the radio, and then runs into TX, which is the input to the SWR meter. Then we've got one that's marked ANT, and that's where the antenna goes. Now, if I just push that into there like that, yeah, it's basically just making contact with the center conductor, which is the actual transmit element on a quarter wave aerial. If I rotate this back round, if I put that to cal, I'm still never going to get full scale deflection on this, because the scale's just not good enough. I really needed a meter which would go down to 1 or 2 watts to get a better chance of getting a full scale deflection. Now, if I key this now, hopefully I'll get a better power output. There you go. It's actually giving me full power output there. Well, as I say, cal is really just to get full scale deflection, but it's actually showing 0.5 watts. So it's obviously giving me a bit of an indication of some signal strength, and it could actually be telling me that it's giving me 0.5 watts there. So I'm not 100% up on how VSWR meters work, but I'm basically giving you a few pointers so that you can get an antenna which will work potentially better than the original one in the walkie-talkie, and you'll be able to plug it in onto a large case radio system like this. So if I now put this to forward signal and key it again, you can see that it's actually not giving full power output there. It's giving say 0.3 of a watt, something like that. If I put that to reflected, it's going to give, right, it's actually saying there's virtually no reflected energy due to the antenna being quite a good length of tune. Basically you tune it by just snipping bits of wire off, working slowly down its length until you get the best forward signal strength, and so on that scale you should get the highest signal strength you can get there for its forward energy. On reflected you should get the lowest deflection. You can see there, it's just moving just a fraction. Now then we have SWR reading. Now you want this to be as low as possible, so I can't get a proper true SWR reading. For instance, that top scale there where it says cal in red and 1 over at that end, so, and then you've got 1.5. Now if I could get full scale deflection on this meter, I'd be trying to get this antenna tuned to around about the 1.5 point, but because I can't get a full scale deflection, I'm just trying to get the needle to move as low as possible. Now I'm going to key up with it in SWR position and see, and hopefully the needle won't move too far. There you go, hardly any movement. So that is basically telling me that I'm on the right track there. So that's 14.4 centimeters of conductor, just basic copper wire, no loadings, nothing fancy. But the forward signal strength is not up at the 0.5 of a watt, which is where I would try and get this to read if possible. Now I've got another antenna which I've cut out of some earth wire. That one, you can see, is a little touch shorter. If I measure the insulated bit, that is actually measuring at 13.5 on the insulated section. Just to recap, my other one was measuring about 14.4, 14.3ish. So we'll give this one a quick go. Again, I'll try and fit that into there. Right, now let's see if this performs any better. This antenna's fractionally shorter. Right, I think we can see that one has actually gone a little touch higher on the needle, so it's actually saying that it's producing a little bit more forward energy. Now the thing is, has it got reflected energy which is coming back and losing power? Hardly anything. So that's actually saying that 13.5 centimeters is actually a better length than 14.4. If we go to cal, it's always going to be on full scale deflection because I cannot get on full max adjustment there because I can't get a full scale deflection. So that is showing just under the 0.5, and SWR hardly moving again. So that's also a fairly reasonable little antenna. So somewhere in the 14 centimeter length, 13.5 to 14.4 is going to work as a basic antenna. So I've had a bit more of a play and I started thinking, well, I really wanted something that looked a bit bigger than this. Now, as I say, what we could do is you could get, for instance, an old fishing rod, and you could, some of them are hollow I believe, fishing rods, fiberglass fishing rods, and you could put that copper antenna section in the bottom and then just have any length of fake whip that you wanted. Now I had a little bit of a play around and I came up with a bit of an idea on how to make an unusual antenna, which maybe will work better than the basic little quarter wave. Now the idea of this is it's like a quarter wave dipole. Now a dipole antenna, on a dipole you have quarter wavelength of metal connected to the sheath of the coax. So in this case, this quarter wave is connected to the outer casing of the socket. You can see I've just soldered it all up. And this piece of brass pipe is actually a piece of old airsoft barrel. So I'm just making use of junk lying around. So as you'd expect, these are about 14 centimeters in length. So what I've done is I've fed a piece of insulated wire from the center pin in there up inside the airsoft barrel, and then it just continues out all the way. So I've basically used this earth wire. So the total length of the earth wire, which is soldered into the pin at the bottom there, it's actually longer. It's about 31 centimeters in length. So it's actually longer than this ruler. You can see how much by. We could say about 31.5 total. Now the part, the airsoft barrel section, and from the pin there, that goes 18.3 centimeters up, and then the bit which is just the insulated section is 13.4. Yeah, 13.4, 13.5, anywhere in that sort of area, and it'll work. Now this little bit, if you look at some antenna designs, they quite often they have these, what they call, if I remember right, radial elements. Now you could put 4 of these on. You could put 2 pointing out at right angles to these, and this I've arranged in a cross formation, so there's basically about the same angle between all 3 elements. Yeah, that's not counting this center section here, which is obviously just soldered to it. Now I'm going to try this in now and see what sort of results we get. Just a second, I'm going to pause this. Okay, that's now on. Now, as I say, this is just a bit of a play around antenna which I've been working on, and it certainly works better than this big long whip antenna. Now my aim was to try and get the signal strength as high as possible when I put that into forward direction there, and get the SWR needle to move as low as possible. Now it might not be a perfect setup. Let's have a little go. I was playing with this last weekend. Okay, if I put this to forward, it's actually not showing as good a result as I was getting last week. Let's try Cal. Yeah, it's not really saying, in fact, yeah, that, no, it's not actually giving me up to the half watt, so it's potentially not giving me good results today, which is odd. Reflected Reflected still very low. SWR still very low. So forward power. Now when I was using this last week, it was actually kicking over to way past the 0.5 watt. It was kicking over to about 1 watt for some reason on the power signal, which was quite encouraging considering the unit's only supposed to be a half watt power output. So I continued to have a bit of a play around with it. Let's see if it's something to do with these elements, because moving these elements around actually seems to affect the power output I was finding last week. I was getting some quite unusual results. See if I can move this a little bit closer so I can play around with it. Someone getting a bit aggravated probably with me keying the mic. Oh well. I'm going to have a little play around with this antenna and see if I can get it to start transmitting a little bit more power. Okay, I wasn't getting particularly great results on my other unit mounted in the Jeep, so I thought I'll get this backpack radio down, which I made last year sometime, probably near a year ago, and try on here. Now for this one I've used a push to talk handset. See, it's got a push to talk button in the side and microphone and earpiece. So basically they're near enough the two components which came out the walkie-talkie, other than the earpiece is actually, I suspect, the earpiece which came in this unit in the handset, and appears to work quite well. So I've left it in, and it functions with the walkie-talkie quite good. So I've now got this one powered up, and I've got this antenna which I've cut to length and tuned in last week, and that one, let's just take a measurement of it. In fact, it's giving you actually it's giving you a false impression that this is a bit longer. What I've done is I've actually cut this to around 13.5 centimeters, and then I've put the insulation over, but I've left the insulation a reasonable amount longer. See, this is some heavy cable insulation which is a bit stiffer, just to try and make the aerial look a bit longer than it really is. Yeah, so I can unscrew this, but basically you can hear the Jeep radio's picking up the signal from this. if I speak into it, you can hear in the background the Jeep radio receiving. Yeah, so if I take this aerial out of here, so say this one is I think a 13.4 unit. Also, this backpack radio I've made runs off a higher voltage. The walkie-talkie itself was supposed to give a longer range. Now I have a suspicion as to how these units, these little walkie-talkies, actually get a better range, and I'm actually just suspecting it's by putting one extra battery in the casing, but I'm not 100% certain of that fact yet. So I'm going to screw in my VSWR meter into this unit, and hopefully you'll see that this unit gives a better power output. I might prove myself wrong now. I was messing with this last week and it did seem to be the case. Now what I have here is I've got that little piece of copper wire which was the 13.5 centimetre. I've got this to forward signal power, maximum deflection adjustment on the scale, because as I say it's still a low power machine. And let's see what this gives. See, it's actually saying that it's transmitting just over half a watt on this little piece of wire, which is not bad. If I have a look at reflected signal, it's actually reflecting a little bit back, so it could be that that is in effect deducting that little bit which is over the half a watt, so it could be that it's actually sending out just on the half watt. If I put it to SWR, you'll see it's fairly low SWR. So maximum scale deflection on the SWR range up there on the top, maximum scale, it gives about 1.6, 1.7 on that scale. So all I can do is look at this in terms of it being a percentage of that deflection. So I want my scale deflection to be as low as possible. So I would say it could be giving out a SWR of about 1.5, 1.7 possibly. With a little bit more work you could tune it and get it even better, but it's a very crude way of setting it when we haven't got a proper full scale deflection in the calibrate scale. If I put this to cal, see what this gives. See, it gives it much bigger, much more deflection on the calibrate scale because of the higher output of the signal. See, that's going to, if you look at the power scale at the bottom, that's going to nearly a deflection of 3 on that power scale, but we should really be looking at the SWR scale on the top, which is going to near 5. So let's try my unusual antenna which I've been playing around with. Which is just here. Now there was a reason why I was sticking with this last week. Whether I was getting better reception, I can't remember now. But if I flick this, I've left it on cal, and it's giving about 2.5 on there. So again, it's not really giving as good a signal output as the basic short piece of copper wire. Right, forward signal. There again, similar sort of performance, just over 0.5. Now, when I was playing around with this antenna, I was getting varying degrees of signal. I was being able to tune it, and the way I was being able to tune it was by moving these radial elements up and down on this piece of brass pipe, brass airsoft barrel. So by sliding it up and down, I was actually varying the properties of the antenna, the output signal, the SWR, all sorts of things. Also, I could tweak them by moving these elements up and down. In the end, I found it best to have it in that arrangement. As I say, I don't seem to be duplicating the good results which I was getting last week. And the SWR is actually a little bit high. So, in reflection, this basic little piece of wire still seems to work better than my complicated antenna, which is a shame, but it does give you a simple result which you can duplicate quite easily, very cheap.